Hello, how's it going? In this video, we are going to get validation layers running so that we can get error reporting for our program. Before I jump into the theory, I want to quickly just run through some changes that I've made. And yes, there will be changes between videos, but refactoring is not super exciting, and it's not really the point of this tutorial series. I'm not teaching you how to write 1,000 lines a minute, but I think it is important to see what's happening. So here's how my engine, well, this is how I intend my engine to run. A lot of this is the same. We'll go ahead, make our instance, and then we'll have something called a dispatch loader dynamic based on the instance, and we will use this when we create a debug messenger, which will be printing errors back to the console. Okay, but just a little change that I made here is that a lot of these deletion functions we based around a Vulkan instance, and so I've set this up so that my queue of deleters is understood to be a set of functions which take a Vulkan instance as their argument, return nothing. So if we were to look over at the instance creation, where we've made that instance destructor function right down the bottom here, here's how it goes. We take in an instance as our argument, and our destructor is to destroy the instance. Anyway, that's been our little 5-minute summary. Okay, so validation layers. What are they about? By default, Vulkan gives us no error reporting. It's not in there, it's opt-in. But when we do have error reporting and such, this is basically how it works. Let's say we are calling a Vulkan function, which could potentially have some dodgy arguments. A validation layer intercepts that call, checks the arguments. It can correct some very simple errors, sometimes. Then it passes the call along to the Vulkan driver. And if any errors or suboptimal usage or anything was reported, then that can be passed back to a callback function. Requesting validation layers occurs at the point of instance creation. We need to put on the following names. To request the extension, we need to put on this vkxt debug utils name, and to put on the layer, we need to put on this name vklayer Kronos validation. Let's go ahead and do that now. So here I'm setting up my instance. This is the same code that we saw before. I'm being a little unorthodox in the sense that for my enabled extension names, rather than something like a vector of strings or a vector of character pointers, which again, I'm getting off on a tangent. But anyway, I decided to just go fully old school and just go with a C-style array of strings. It doesn't matter at all. So we're going along here, we're popping on or adding on all of our GLFW extensions that we fetched up above. And what I need to do now is put on the validation extension. So I want this to go on the end. Right, so we want, let's go, I don't know why I can't type today. And there's actually a very handy macro that we can use, and that is there we go, debug utils extension name. And we can hover over it and see that it is in fact vkxt debug utils. Excellent. Now let's have a look at our layers. So again, we've got no layers, but if we're in debug mode, then we'll have one layer. Think of it that way. And then we've got this array of strings, the enabled layer names, and currently there's absolutely nothing on it. So we can go enabled layer names, thing number 0 is, we'll go So that didn't take long. So as you can see, I know it's a bit of a forest of code here, but we've gone on, and if we're in debug mode, then we stick on the debug extension. That's for the enabled extensions, which we're going to request upon device creation. And then down below, if we are in debug mode, we're going to stick on the validation layer name. And this is just setting up a request. When we go to create the instance, Vulkan will look through this and say, okay, you're requesting validation layers, let's enable them. And by the way, side note, I've got this sort of print list function, which if we look through the logger, here we go, print list. All this is doing is it's expecting to get a list of strings and a number of strings, and it will just look through and print them all. Cool. So let's say we've gone ahead and requested those. Probably a pretty decent question to ask is, how can we check what our instance will support? We're going to create an instance. It would be good to know, which extensions and which layers we can support. So this is the C header function prototype. As we can see here, this is an optional argument, the first one. So we could be checking extensions based on a given layer name, but we don't need to. But basically, we would pass in a property count, or the first time we run this, we'd pass in the property count and nothing, and null for the pointer to properties, and then that property count would be populated, and then we would call it a second time with the property count and a pointer to an array ready to accept those extension properties, and that will be populated. You'll see that the C++ version of this is considerably simpler, but yeah, this is how we would do that. And we can also check which layers our instance will support. So we have this enumerate instance layer properties function, again, property count and pointer to properties. Okay, but like I said, the C++ version is considerably simpler than this, so let's have a look at our implementation. This will not be a code along this section, we're just simply showing it. So let's say we've set this up, we've got all the layers and extensions we're going to request, then we go ahead, and before we create the device, it might be good just to check that these things are supported. So this function is defined up above. It takes a bunch of extensions and layers which are being requested and basically looks through them. So we call this enumerate instance extension properties function. And as I was saying before, we're doing no exceptions, and so we need to explicitly get the value from this. And then just because it would be nice to see what our instance can support, I've got this print extensions function, which will take that vector of extension properties and print them out. So I'll just quickly go over there. The way this works is we will look through every element of the vector, and then this extension properties has a field called extension name, and we can just print that out. And it's the same for layers. So we look through the layer properties, and then each of those layer properties things has a field called layer name. We can print that out as well. This is just nice to see. It's nice to see what the computer can support. But otherwise, it's pretty much just doing basic string comparison. So what I'll do, just to see this, is I'm going to just get rid of this other stuff. I won't worry about that yet, but I'll give this a go and see how this is working. So we can see that we are requesting KHR surface, Win32 surface, and debug utils. And we can also see down below all of the extensions which the instance can support. We have all of these things, lots of them. And if we were to look by hand, we can see when we want KHR surface, we'll go no match, no match, no match, up until this point here. Then we go, all right, we've got KHR surface. Then we go ahead and look at the next extension, and so on. It's really just checking elements are in a set. And as we can see, all of those extensions and that layer, it's all supported. Onwards and upwards. We've got validation, basically, but the next thing I want to do is I want to register a callback function, which will essentially print out error messages to the console. Now, in order to do this messenger creation it's not really core Vulkan. It's supported for sure, but it needs to be queried based on the Vulkan instance, because different vendors may have different implementations for this specific thing. Of course, different vendors are going to have different implementations for everything, but I hope this makes sense. It's not core Vulkan functionality. The procedure must be fetched. So in the C version, there is a function which retrieves a function pointer called instance get procedure address or something like that. But in C++, we actually simply create what's called a dynamic dispatcher object. And then for some functions, we can pass that dynamic dispatcher in, and that will, under the hood, do the job of fetching function pointers. So that's what I'm doing over here in the renderer. I'm saying, all right, I'm constructing a dispatch loader dynamic based on my instance, and I need to pass in a function pointer, or pointer to the function which is going to be used to query that instance procedure address. And the really important thing about that is then used to create a debug messenger. And if I want to use other instance extensions, it can be used for that too. So I'll just go over to my logger, and in my logger, I've got two things which are really important. One is this function which will make a debug messenger, and the other is the callback function which will actually do the printing. So think of it like this function here will make a debug messenger, and this function here is the messenger used by the debug messenger. I know, right? So in order to make a debug messenger, we have this struct called a mouthful is what it's called. It's a vk debug utils messenger create info ext, and it takes all these things. But the really important things are the message severity, the message type, and the pointer function, or the function pointer to the callback. So here I'll go to my logger source file, and I'll go down to this bit here, which says make debug messenger, okay. And yeah, I mean, mostly it's set up for us. So I'll go ahead and construct this. We'll have this create info. Okay, so first up, I've just got my flags, standard flags here, but then I've got a bunch of these I'm looking at my message severity. So I'm gonna go with everything. We have all of these, okay? I'm gonna say, right, I'm gonna print out in the case of an error. I'm going to print out in the case of simply providing info. Going to print out, you can see what I'm doing here in the case of, in verbose cases, and warnings. So everything. And then I'll have message type. And similar, I guess I'm not doing any device address binding, so I won't do that. For now, we'll just go general. Okay, so we've set our flags, message severity, and our type. And then I'm going to need a function to the callback, the function which will be executed. I've got this right up above. It's named debug callback. I'll take a look at that in a second. So I'll just refer to that, debug callback. And then this user data is basically an arbitrary data package which can have custom info in order to, like if we were to look up at this debug messenger, it can take in an arbitrary payload of data. And this could be important, say, if we were doing some really fine-tuned error checking, where we were passing in some custom info. Like, let's say we have a function which might be causing an error. What we could do is we could write to a bunch of info inside some struct, and then call the function. And if that function generates an error, the debug callback could then look inside that struct and fetch the info. And this would be really good, I guess, if we had, for instance, if we had a whole bunch of threads which are operating on different objects. One of those threads threw an error. Say every thread has a command buffer or something. One of those command buffers throws an error. We've got an error that says a command buffer wasn't done properly. And it's like, well, great. What does that mean to me? Well, if we have like a naming struct for every thread, then we can see sort of the thread ID or some unique info to indicate which of the threads was actually throwing an error. And that might help for some more fine-tuned cases. Right now, it's nothing. It's nothing. So far so good. Let me just create the messenger first and destroy the messenger, and then I'll worry about that callback. So for the messenger, I'm going to create it by my instance. So I'll say get my instance, and we'll go create messenger. And we're going to need a pointer to our create info. Sorry, what am I thinking? Not a pointer, a reference. I need to lie down. Then we'll have our allocator, and then we'll have our dispatch loader. Just like that. That will create our messenger for us. Then it comes time to destroy the messenger. In order to destroy the messenger, we can say, hey, instance, because that's passed in as an argument. Destroy the messenger. And then we're going to need the allocator and the dispatch loader, which, as we can see, the dispatch loader has been, we'll get to that in a second, the dispatch loader has been captured. It's in the capture list of the Lambda. So we've got that, and this is throwing an error at me as it should, because I'm going to deal with the handle. Now, just a quick sort of reminder on what a handle is. So in Vulkan, every Vulkan object is represented by a handle, and a handle is a 64-bit unsigned integer. It's like a unique memory location or something. It's not a memory location, but it's a unique lookup for the Vulkan instance. So say this handle is like FFF7 or something, it doesn't matter. Vulkan is able to retrieve the underlying messenger object based on this handle. Now, on the other hand, like a VK, a class, a wrapper class, essentially we can think of it as a class that contains the handle as one of its fields, but it also contains a whole bunch of functionality, a whole bunch of methods that can be performed with that object. So that's why, for instance, I can go instance, and then instance has a method called destroy debug utils, like that. Normally that wouldn't happen. Anyway, hopefully that makes sense. So we are now creating and destroying the messenger, and I'll just briefly have a look at what that callback is. So this is a lot of boilerplate, which is why I'm not going into a lot of detail on it, but this is sort of expected that it will return, this is a function which returns a Boolean, and it takes all of this info in. So it takes in the message severity, the message type, callback data, and the user data. Now the callback data is a payload of data which is populated by the validation layer. So it will have things like the string, the message, the error message, and as I was saying, the user data is a payload of data defined by us. So we have access to all of this. Just like that, and everything should be created for us. I know, it's super exciting at the moment. We can just close down, and as we can see, the order is maintained. So we close the window, we enter the destructor, we delete the debug messenger, and then we delete the instance. If we did this in the other order, we would have problems. And congrats, we did it. We've got a debug messenger and validation layers for our program. In the next step, we'll be having a look at physical devices. I hope to see you there. All right, bye.